Yesterday in class, we had a general overview of what statistics was. And just as a refresher, we said statistics involved collecting data, organizing, analyzing data, making predictions, drawing conclusions from our data. To get a little more specific today, statistics can be broken into two categories. The first is descriptive statistics, and that's the piece that involves the actual collection, organizing, summarizing, and presenting of your data. The second piece is inferential, and that's the piece where we generalize, we make generalizations from samples to populations. A sample would be a subset of a population. Perform estimations and run hypothesis tests. We spend a lot of time second trimester running hypothesis tests. We're going to determine relationships among different variables and also make predictions. Inferential statistics uses probability theory as well. So before we get into maybe clarifying a few more pieces, some of those underlined words might be new to you, let's just take a little pause here and make sure that we have an understanding of the difference between descriptive and inferential statistics. So we have the last 4 semesters an instructor taught intermediate algebra. The following numbers of people passed the class. So take a look below, examples A through G, and tell me which of the following can be obtained purely from descriptive or which would be obtained by inferential. So just take a little pause here and try out the example. With letter A, the last 4 semesters, an average of 15 people passed the class. That would be descriptive. I'm just going to go ahead and put a D there for descriptive. The next time, so now in letter B, now we're making a prediction. We're drawing an inference. Next time the instructor teaches it, we can expect 15 people to take the class. So that would be inferential. Letter C, this instructor will never pass more than 20 people. We're not saying that they never have, but we're making, again, another prediction. So that's inferential. The last 4 semesters the instructor taught it, no more than 20 people passed the class. Now that's actual descriptive. That is fact. Only 5 people one semester because the instructor was in a bad mood. That's just making an inference. The instructor, letter F, the instructor passed 20 people the last time to keep the administration off of his back for poor results. Again, we're just making an inference. Letter G, the instructor passes so few people in his intermediate algebra classes because he doesn't like teaching that class. And again, that would just be another inference. When we defined inferential statistics, we talked about comparing or finding relationships between variables. A variable is just a characteristic or an attribute that can assume different values. So it might not necessarily just be we're looking at a variable being X or Y. A variable could just be something such as eye color. A variable could be your height. It could be your weight. It could be letter grades in a class, whatever it happens to be. So we're not just talking about it has to be X or Y equals. A random variable is one that is determined by chance. If we're talking about data, or you might say it data, whichever way you like, potato, potato, values of your measurements or observations. That's where your data comes from. If you have a data set, that's a collection of data values. Each data value could also be referred to as a datum. When we defined inferential statistics, we talked about generalizing from samples to populations. A population is all subjects being studied, so it could be all the students at Western Dubuque. It could be everyone in Iowa. It could be something also like all the trucks on the road, things of that nature. It doesn't just necessarily have to be people. It can also be objects as well. A sample then is a group of subjects that you select from your population. So it's a subset of your population. Samples are easier to gather than trying to collect data from an entire population. We also alluded to hypothesis testing in our definition of inferential statistics. Hypothesis testing is your decision-making process for evaluating claims about a population based on your information that you obtain from a sample. And again, that's where we're going to spend most of our second trimester, is looking at hypothesis testing. It's not always ideal to gather data from an entire population, so we gather data from a sample and then use that information to make generalizations about our population. We just defined variables and data, so now let's look at specific types of variables and types of data. Qualitative variables, they can be placed in distinct categories according to a characteristic or attribute. So for example, gender, eye color, your religious preference, your nationality, your area code, the grade you're in high school, whatever the case may be, the sport you're in or the activity that you're in, those are all qualitative variables. Thank you. If you have a quantitative variable, I think of quantitative as quantity. So when I think of a quantity, I think of numbers. So quantitative variables are numerical, and they can be put in a specific order, or you could rank them. Some examples of those would be age, height, weight, and temperature. So qualitative, you have a specific quality or characteristic. Quantitative, I think of quantity. Quantities are numerical. There's two specific groups of quantitative variables. The first one is a discrete variable. Discrete variables have values that can actually be counted. So it could be, for example, the number of students in class. I could physically count how many students are in class today. The number of emails you receive each day for a month. Then the other type of variable, the other group type, is a continuous variable, and that can assume any infinite number of values between any two specific values. Those are obtained by measuring. They oftentimes include fractions or decimals. Some examples of those would be length, temperature, time, and mass. And now you might be thinking, Ms. Gelly, so how can a length assume an infinite number of values between any two specific values? How's that possible? If you measure my height at 5'7", that's it. I'm just 5'7". What happens if we're making measurements? You're restricted by your actual measuring device. So maybe you're measuring my height with something that only has feet and inches. So if you measure me at 67 inches, that's all your measuring device has, that's it. Maybe I'm really 5'7.5" inches. Or maybe I'm 5'7 3/10 inches. I'm just limited to my measuring device. So a little more specific with those continuous variables. Like I had mentioned, answers are rounded because we're limited by our measuring device. So similar to the example of my height, if we have a recorded value of 85 inches, that can mean any measure from 84.5 up to, but not including, 85.5. And those are just our basic rounding rules. So what we do is we establish what are called boundaries for continuous variables. So a measurement of 85 inches could be anywhere from 84.5 up to, but not including, 85.5. So just to elaborate a little bit on the idea of the boundaries, If your recorded value is 18 inches, what I like to do, my little trick for this, I add a 0 on to the end of my value, and in this case I had to put a decimal point there, otherwise it becomes 180 instead of 18. I look at the last 2 digits. To get the lower boundary, I subtract 5. To get the upper boundary, I add 5. So just take a little pause here and see if you can take a shot at finding the boundaries for the other 2 measurements in this table. So again, I like using my little trick, 1.7, I put a 0 on the end, I subtract 5, so I get 1.65, I add 5, 1.75. Now remember, with the boundaries, 1.65 would be included, and it would be everything up to 1.75. That upper boundary would not be an included value. 5.42, I put a 0, subtract 5, and then I add 5. That is the easiest trick I know for writing boundaries. If you need any clarifying on that when you're doing your practice questions, please ask. I'll be more than happy to walk through some more with you. So take a moment here and pause and see how you would classify each set of data. Would it be considered discrete or continuous? Remember, discrete, you can actually count it, 1, 2, 3, 4, 5, etc. Continuous, the values could be in that range of values due to the limitations of your measuring device. So in number 1, the number of suitcases, I'm not going to have half of a suitcase or a third of a suitcase come rolling through, so this would be discrete. I'm just going to put a D for discrete. The height of corn plants, again, the height, that's going to be restricted by whatever our measuring device is. So that's going to be a continuous. The number of ears of corn produced, I can actually count how many are produced. So it would be descriptive. Number 4, the number of green M&Ms. I can physically count how many. I don't have to measure it. I can just count it. The time it takes for a car battery to die. Time, again, we're looking at a measurement. So that's going to be continuous. Whether your timer stops at tenths of a second, hundredths of a second, thousandths of a second, that's going to affect your measurement value. The number 6, the production of tomatoes by weight. Again, we see another measurement, so we're going to be restricted by our measuring device. So that will be a continuous variable. Our measurement scales. Measurement scales are used to classify the variables by how they are categorized, counted, or measured. There's 4 different levels of measurement. The first is called the nominal level of measurement. It has mutually exclusive categories, which means they don't overlap. The data in this level of measurement is distinguished by name only. There's no order or rankings at all. A few examples of nominal level of measurement: the actual colors of M&Ms in a bag, gender, political parties, courses that are taught by a teacher. So just a few things. I remember nominal, and name both start with N. This level of measurement is by name only. Second level of measurement is called ordinal. It classifies data into categories where the data values can actually be ranked. Precise differences between the ranks do not exist, so they are in a specific order, but there's not an actual measurable difference between them. So some examples: movies on a certain TV show are classified as 2 thumbs up, 1 thumb up, or 0 thumbs up. So there is a specific order there, there is a ranking, but there's not a measurable difference between those ranks. Voters are classified as low income, middle income, or high income. You might be thinking, Miss Golly, there is a measurable difference. There's not a measurable difference until we establish dollar values for low income or dollar values for middle income. So right now it's just low, middle, and high. There's a specific order, there's a rank, but there's no measurable difference between those. What I like to remember, ordinal sounds a lot like order. Things are put in a specific order. Our third level of measurement is called interval. Interval does rank the data. There are actually measurable differences, though, between the different values. There is no meaningful zero, and by no meaningful zero, zero does exist, but 0 doesn't mean 0. So for example, if we're measuring temperature, there is 0 degrees, but it doesn't mean that there's no temperature, that temperature doesn't exist. So 0 doesn't mean 0. Doesn't mean there's not temperature. There is temperature, it's just measuring at 0. Another example of that would be in women's pant sizes. There is a size 0. Size 0 doesn't mean that the pair of pants doesn't exist. There is actually a pair of pants for a size 0. So 0 doesn't mean 0. If you try to set up a ratio with interval level measurement, the ratios do not make sense. An example of that, we have a brownie recipe, calls for brownies to be cooked at 400 degrees for 30 minutes. Would you get the same results if you knocked the temperature down to 200 degrees and cooked them for 60 minutes? What about 800 degrees for 15 minutes? So just because I double the temperature doesn't mean I can cut the time in half. So the ratios do not make sense for this level of measurement. Again, 0 degrees does not mean that there's no heat or no temperature. Our last level is ratio. Has all the same characteristics as interval, but there exists a true 0, and the ratios actually make sense. So some examples: height, weight, time, age, salary. On all of those things, 0 means 0. So if something has a height of 0, it doesn't exist. It's not there. 0 means 0. If somebody is 0 years old, that person does not exist. If you're looking at your salary, if I make $0, 0 means 0. I'm making no money at all. So 0 actually means 0. There's no height, there's no weight, no time has passed, no person exists, you make no money. 0 means 0. Now I know there's 4 different levels. It can take some time and practice to kind of wrap your head around all 4 with their characteristics. So let's take a pause here and try out. There's 13 different examples. take a pause here and see if you can determine which of the 4 levels of measurement each of these would be. So for the first one, we have percentage scores on a math exam. So with percentage scores, if I have a 0%, it means that I earned no points. 0 means 0. So we're looking at ratio. Letter grades on an English essay. Letter grades can be put in a specific order, but there's no measurable difference. I'm not given the percentages, so I can't actually measure the difference between an A and a B. If you attach the percentages, then it becomes like number 1. But if we're just looking strictly at the letters, all we can do is put them in a specific order. Order, ordinal. In number 3, we're just talking flavors of yogurt, not what one I like best, or which one has the most calories to least calories. We're not putting them in any kind of order at all. There's nothing to measure there. It's just the name of the flavor. So if it's just the name, it's nominal. Instructors classifying easy, difficult, or impossible. Now you're putting classes in a certain order or a certain rank. So it would just be ordinal. Employee evaluations classified as excellent, average, or poor. Again, we're putting them in some type of order. We are ranking them. Number 6, religions. We're not saying which one we have a preference for. We're not ranking them at all. We can't measure the difference between them. So we would just only be able to put them by name. Name and nominal both start with N. Same with political parties. I'm not ranking them in my order of preference. There's no measurable differences between them. So they're just by name alone. Commuting times to school. If I think about times, time is a measurement, so I'm looking at either interval or ratio levels. And if I am traveling for 0 minutes, I have not traveled at all. 0 means 0 time has passed. So if 0 means 0, we have ratio level. Number 9, the years AD of important historical events. If you're looking at AD, there is no year 0. So we don't have that 0 means 0. So this would be considered interval. There is no meaningful 0. Ages and years of statistics students. If you are 0 years, you do not exist. You might be thinking, Miss Golly, what about a little baby? Maybe it's 6 months old. Well, then you would be 0.5. You would be half of a year, not 0. So this would be ratio. 0 means 0. Ice cream flavor preference. So if you do have a preference, you're putting your flavors in a specific order. But we can't measure the difference between those. Chocolate, vanilla, strawberry, I'm going to put them in some specific order. So I'm ordering them, so ordinal. Amount of money in a savings account. If I have an amount of money, if I have $0 in my savings account, that means I have nothing there. 0 means 0. So we have ratio. If we classify students by their reading ability as above average, below average, and normal, we're putting them in a certain order. We've ranked them some way, but we don't have a specific set of scores or anything that we can really measure. So we're just putting them in a specific order. That's all we can do. Your assignment. Now I realize you have watched this video over the first 2 sections. I do ask that you take the time to read those first 2 sections though. Yes, you've listened to the video, you've taken notes, I'm hoping, but sometimes it just helps that information a little more and to pick up maybe on a few other key pieces by actually reading the sections. Then I do have a few practice questions for you to try. I have posted the answers to those on my website. The odds are in the back of your book, but the other answers and the evens are posted on my website for you.